This strange occurrence was expected to happen, but they didn't know exactly when. Upon more detailed examination, the astronomers from NASA confirmed that the phenomenon will start on November 15th at 3 a.m. and will most likely last until November 30th, 4:45 p.m. According to experts, this blackout will be caused by an astronomical event between Jupiter and Venus. There was even a detailed 1,000 pages document written by Charles Bolden, head of NASA, explaining the strange event to officials at the White House. According to the report, during this specific period Jupiter and Venus will come in close proximity of each other and will be separated by just 1 degree. Venus will move to the southwest of Jupiter, and as a result it will shine 10 times brighter than Jupiter. Venus' bright light will heat up the gases in Jupiter, causing a reaction which will release an absurdly high amount of hydrogen into the space. This reaction will come in contact with our Sun at 2:50 a.m. on November 15th. Once the hydrogen reaches the Sun, a massive explosion is bound to occur on the surface of the Sun, increasing the temperature to more than 9,000 degrees. The whole process will generate so much heat that the Sun will change its color into a bluish shade. Once this happens, the Sun will need a minimum of 14 days to restore its normal color and temperature. As a result of this strange phenomenon, the Sun's light will be seen much dimmer from the Earth, and hence the 15-day blackout NASA is talking about. We do not expect any major effects from the blackout event. The only effect this event will have on Earth is an increase of 6-8 degrees in temperature. The polar cap will be mostly affected by this. No one should worry much. This event would be similar to what Alaskans experience in the winter, Bolden said.
It has very, very few stars, but when astronomers were observing it, they noticed that these stars weren't drifting apart, they were staying together, so they observed it further and noticed that it was made entirely of dark matter, about 99.99% dark matter. Now, the reason this is such an exciting discovery is because it really is the largest known galaxy of this size, about the size of our own galaxy, the Milky Way, which is why scientists are now calling it our dark twin galaxy. And it's something that I want to explain what dark matter is. So dark matter, according to experts, roughly 80% of the mass of the universe is made up of it, and it's material that scientists cannot directly observe. Now, this bizarre ingredient does not emit light or energy, and most of the material that we see in the universe is called baryonic matter, which is composed of protons, neutrons, and electrons. Dark matter may be made of this baryonic or non-baryonic matter, and in order to hold the elements of the universe together, experts believe that the universe has to be made up 80% of this dark matter. Anya.
And how does this discovery change everything that astronomers knew about the universe?
So this really challenges all of the notions that are out there about how the universe came to be formed and how galaxies are formed. Prior to this, astronomers had believed that they were starting to understand the makeup of the universe. In other words, they believed that the ratio of the matter that made up the universe was 5 parts dark matter to 1 part of what's considered traditional matter. But now with this discovery, they're realizing that that ratio doesn't exactly add up, because you can have very few stars with even more dark matter. So they really have to go back to the drawing board, which leads them to believe that they really don't know as much about the universe as they thought. But the good news is that they can now look for other galaxies made of dark matter that are maybe a little bit closer to Earth, which would then possibly even open up the door for them to discover what dark matter is made of, maybe even a dark matter particle, Anya.
Scientists at NASA have given us some amazing images, and they've discovered there's actually an enormous dark hole over our sun. Corey Powell's editor-at-large, Discover Magazine, here to look at these images. Nice to see you, Corey.
Yeah.
What is this?
Weather map on the sun. You'll notice part of the sun is missing. So this is a picture of the sun in ultraviolet rays. What you're seeing is this is 3.5 million degree plasma erupting from the surface of the sun. This part that's missing, the reason it's dark, is that whole chunk of the sun basically ripped off, blew out, and is coming our way at about 2 million miles an hour.
Our way.
Our way.
That doesn't sound good.
Well, I mean, this kind of thing happens all the time, but you don't very often see something that big. So I'm going to go all Carl Sagan on you here for a second. So this is about 80 times as wide as the Earth. If you're looking at the Earth on this scale, it's about that large. So this is an incredible chunk of the sun that's flying out. What happens when it hits our planet, it causes auroras, it wiggles the magnetic field. The thing you really worry about is it can disrupt your GPS, it can mess with your communication satellites, it can mess with your power lines.
Is that like a solar flare? Or?
So yeah, so these hotspots are where the things are really kind of intense and bubbling. This is where it's basically reached the point where it just kind of completely blew off. You're actually not seeing the hot gas here because it's no longer on the sun. It's coming into our face.
Did we ever know this before, or did we not take note of it?
Well, we know it's really very recent that we've even been able to see these things, and so we kind of knew, there's this constant low-level thing, a few $1 million a year damages, more or less, just our solar satellites, power lines, things. We knew that the sun was messing with us, and we didn't exactly know why. Now you see why, and the real worry is this is actually, believe it or not, this is a small one. This is a minor one.
Wow. Can you tell us what this means then?
So what this means is, this is what the sun does all the time, and we don't really know why it does it. There's an 11-year cycle of solar activity, and right now we're going into a time of peak activity. And that's when all those things I was talking about before, we really need to watch for your power lines, your satellites, for all that.
But you just said something there. You said it happens all the time. If it happens all the time, is there a real risk to us? Or are we just noticing now?
Well, there's two parts. I mean, there's the stuff like this. Like I said, this is actually not even a particularly bad one. So this is what happens all the time that we weren't really noticing, that now we're starting to understand and forecast. But there are much more intense ones. There was a giant solar flare in 1962, right before we really had a whole lot of satellites, an even bigger one in 1859. Wow. And if something like that happened again, that could cause a global blackout.